Lesson 5-2 is on medians and altitudes of triangles. The first segment we're going to take a look at is the median. The median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So in this diagram, segment AM is a median of triangle ABC. You can see that it goes from the vertex A through the triangle to M, which is the midpoint of segment CB. And remember, that's designated by these little hash marks here. So we can also say that CM is equal to MB. Let's take a look at an example using a median. So here's another triangle ABC, and this says find the length of AB, segment AB, if segment BD is a median of triangle ABC. So if BD is a median, then D is the midpoint of AC, and that means that AD is equal to DC. So let's plug in the algebraic expressions we have there to find x. Even though that has nothing to do with AB, we first need to find x. So x plus 3 equals 2x minus 17. And solving for x equals 20. And then we know from the diagram that AB is equal to x minus 7, or 20 minus 7, so the length of segment AB is 13 units. Since a triangle has 3 vertices, it also has 3 medians. In a triangle you can draw 3 different medians, and the point where they intersect is called the centroid. So in this triangle, P is the centroid of triangle ABC. You can see that's where all of the different medians intersect each other. We also have a theorem for the centroid. It says the centroid of a triangle is 2/3 of the distance from a vertex to the midpoint of the opposite side. Okay, so let's take a look at what that means. If P is the centroid of triangle ABC, then segment AP, so that's from a vertex to the centroid, the length of that segment is 2/3 of the length of the whole median. AP is 2/3 of AK. Similarly, BP, from the vertex B to the centroid, that length is 2/3 of the length from B to L, the midpoint of the opposite side. And the last one, CP, is going to be 2/3 of the length of CJ. The centroid is 2/3 of the distance from the vertex to the midpoint of the opposite side. Let's take a look at an example. So in this triangle we have 3 medians intersecting at the centroid, which is point Q, and we're told that if FC is 15, so FC is a median, we need to find FQ and QC. So QC is the longer segment, so QC is actually 2/3 of the length of the whole median, which is FC. So QC is 2/3 of 15, or the length of QC is 10 units. Okay, to find the length of FQ, we can say that FQ plus QC equals FC. And that should look familiar to you as the segment addition postulate. So we don't know FQ, but we know QC is 10, and we know that FC is 15, so the length of FQ is 5. Another segment that we're going to run into in a triangle is called the altitude, and you may be familiar with this from finding the area of a triangle. The area of a triangle is 1/2 base times height. The height of a triangle is actually the length of this altitude, and the altitude is a segment that's drawn from a vertex, and it is perpendicular to the opposite side. So here in triangle ABC, segment CD is an altitude of triangle ABC. Let's take a look at an example using the altitude. This one says find the length of BC, segment BC, if AD is an altitude of the triangle. Well, if AD is an altitude, then angle ADC is going to be a right angle. Because remember, an altitude is perpendicular to the opposite side. So angle ADC needs to be a right angle. So that means the measure of angle ADC is 90, or substituting in the algebraic expression we have for ADC, 4x plus 10 equals 90, 4x equals 80, or x equals 20. Now what we need to do is to find the length of BC. So BC is equal to BD plus DC. There's segment addition postulate again. And BD is 2x. DC is 3x minus 4. And then let's substitute in 20 for x. And that's going to give me 40 plus 50, which is 90. Oh, I'm sorry, 40 plus 60 minus 4, which is 100 minus 4, or the length of BC is 96 units long. And since a triangle has 3 vertices, it also has 3 altitudes. You can see I've drawn them here in triangle ABC. AF is an altitude, BG is an altitude, and CD is an altitude, and they intersect at point P, which we call the orthocenter. Unfortunately, the orthocenter doesn't have a theorem, so we have no problems related to that, although I do like to think that the orthocenter kind of sounds like where you might want to go to get your braces checked. But regardless, that's what the orthocenter is, the point of intersection of the 3 altitudes of a triangle.